This presentation covers the paper entitled Techniques for Multiple Room Connection in Virtual Reality, Walking Within Small Physical Spaces. In this work, we explore methods to enable natural walking in VR environments, even when users have limited physical space. Navigating virtual environments through natural walking is challenging, especially in small physical spaces. Most VR users have limited room to move, with an average tracking area of just 2.4 by 2.2 meters, as noted in previous research. The most common solutions, teleportation and joystick movement, allow users to explore larger virtual worlds, but at the cost of immersion. Redirected walking provides a more natural movement experience, but it requires significantly larger spaces, around 5 by 5 meters, to remain unnoticeable. This raises the question, how can we enable natural walking in VR when physical space is limited? Our approach leverages the concept of impossible spaces, a technique that fits larger virtual environments into small physical areas. By overlapping rooms and manipulating the scene, we maximize the available physical space. We introduce three techniques to connect and overlap rooms. Portals, which provide direct, instant connections between spaces. Corridors, which act as transitional areas to guide movement. Central hubs, which serve as navigation anchors connecting multiple rooms. The implementation of portals follows a structured process. First, the system identifies the rooms that need to be connected and calculates their midpoints. Next, the rooms are slightly overlapped to define a shared space where the portal can be placed. A portal is then positioned within this overlap, ensuring proper alignment to prevent disorientation when passing through. Finally, once the portal is active, users can step through it to instantly transition between rooms. For corridors, the system first identifies the rooms and their door positions. Then, it aligns the rooms in a way that optimizes the available physical space. A corridor path is generated between the two rooms, ensuring smooth entry and exit. To maintain a seamless experience, the system dynamically adjusts the user's stride within the corridor, allowing for a natural transition between spaces. The central hub technique adds an extra room that connects all other rooms. The system first distributes the rooms around the hub, ensuring an even layout. Each room is then linked to the hub using portals, maintaining consistent spacing and alignment. If the environment has multiple hubs, they are connected through an additional system, such as an elevator-like transition. This method simplifies navigation, making it easier for users to recall room connections. To evaluate these techniques, we conducted a user study with 33 participants. The virtual environment was a 5-room apartment, compressed into a small 2.5 by 2.5 meter play area. Each participant experienced one of 3 scenarios, using portals, corridors, or a central hub to navigate between rooms. The task was to search for 16 vinyl records placed throughout the apartment. We measured several key factors: presence, using the I-Group Presence Questionnaire; cybersickness, through the Simulator Sickness Questionnaire; spatial awareness and orientation, assessed through environment drawings and Likert scale questions; overall user experience, including comfort, immersion, and naturalness. Our results showed that all 3 techniques provided a strong sense of presence. Participants felt immersed in the virtual apartment, regardless of the navigation method used. When examining cybersickness, we found some differences between techniques. The corridors group experienced higher disorientation scores. The portals group reported increased nausea in some cases. Individual sensitivity played a role, with certain participants reacting more strongly to scene transitions. Participants had similar accuracy in drawing the virtual apartment layout, with about 4 out of 5 room connections correctly recalled. However, those in the corridor's condition had more difficulty remembering room connections. Portals and central hubs made it easier for users to develop a clear mental map. In terms of user experience, participants rated all three techniques highly in immersion, comfort, and natural navigation. This suggests that users can adapt well to any of the three approaches. When looking at task efficiency, portals and central hubs allowed for faster navigation, with completion times around 9 minutes. The corridors group took significantly longer, over 13 minutes, due to extra walking and the lack of visual previews. In summary, our study introduced three room connection techniques that enable natural walking in VR within small spaces. Our research introduced three room connection techniques, portals, corridors, and central hubs, designed to enable natural walking in small VR spaces of 2.5 by 2.5 meters. By leveraging these methods, we aim to create immersive, intuitive, and flexible navigation options within virtual environments despite physical constraints. To evaluate the effectiveness of these techniques, we conducted a user study with 33 participants, focusing on four key aspects: presence, cybersickness, spatial awareness, and user experience. All three techniques provided a strong sense of presence, meaning that participants felt immersed in the virtual world regardless of the navigation method used. This suggests that our techniques successfully maintain the illusion of a larger space, allowing users to walk naturally without breaking immersion. Importantly, the results suggest flexibility in choosing the methods depending on personal preference or the specific VR application. Overall, cybersickness scores were low across all techniques, which is a promising outcome for VR usability. However, we observed that portals and corridors caused mild discomfort in two participants, considered outliers, who were sensitive to stride adjustments or sudden scene changes. While these effects were minimal, they highlight the importance of optimizing transition mechanics for maximum comfort. Spatial awareness was really positive in both techniques. However, additional comments suggested that central hubs were the easiest to recall, as users could rely on a central reference point to navigate. This made it simpler to form a mental map of the environment. In contrast, corridors required more effort, as users had to remember room connections without a clear anchor. Each technique has its strengths. Portals offer flexibility and clear destination previews. Corridors provide a natural and intuitive way to move between spaces. Central hubs simplify navigation by acting as a central reference point. In our future work, we aim to explore three key areas to further improve VR navigation in small spaces. First, we want to investigate hybrid solutions by combining portals, corridors, and central hubs. While each technique has its own advantages, a hybrid approach could allow for more seamless and adaptable navigation. Second, we plan to develop a smart selection system that helps determine the most suitable room connection technique based on user preference, application context, and physical space constraints. By introducing a scoring system, the VR environment could dynamically adjust, ensuring that users have the most comfortable and immersive experience possible, regardless of their available space. Finally, we aim to apply these techniques in museum use cases. Museums often face spatial constraints and require intuitive navigation systems to guide visitors. By adapting our room connection techniques, we could help enhance the visitor experience, making VR-based museum tours more immersive and engaging. By pursuing these areas, we hope to make VR movement more flexible, efficient, and accessible for all users. Thank you for your attention. If you have any questions or would like to discuss this further, feel free to reach out.